Hello. Hello and welcome back to Advent of Code. I'm Arthur, please. We are on day 5 of Advent of Code. We're going to go ahead and tackle this challenge, and then we'll get back to Wheel of Games. I guess what I'm going to do later is I'll do a poll on Twitch, and you can vote for either us to continue the game that we were playing last time, Stuntman GBA, or re-roll. Stuntman GBA will stay in the wheel if we don't finish it, and we can come back to it. But I don't know. That seems like the most reasonable way to do it to me. Anyway, let's jump into the Day 5 problem. Day 5, Cafeteria. As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left to put up wreaths in the dining hall. Resolute in your quest, you investigate. If only we hadn't switched to the new inventory management system right before Christmas, another elf exclaims. You ask what's going on. Probably the inventory management system problem. The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of their ingredients are fresh and which are spoiled. When you ask how it works, they give you a copy of their database. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and then a list of available ingredient IDs. For example, the fresh ID ranges are inclusive. The range 3 to 5 means that ingredient IDs 3, 4, and 5 are all fresh. The ranges can also overlap. An ingredient ID is fresh if it is in any range. The elves are trying to determine which of the available ingredient IDs are fresh. In this example, it is done as follows. Ingredient ID 1 is spoiled because it does not fall into any range. Ingredient ID 5 is fresh because it falls into 3, 5, and so on. So in this example, 3 of the available ingredient IDs are fresh. Process the database file from the new inventory management system. How many of the available ingredient IDs are fresh? There's a few ways you can approach this. Okay, so, I mean, there's a few approaches I could take that are not all that interesting, but they would work. Fresh is equal to I'm overthinking this. Okay. And then I want to sort this, so And then I need to get the IDs. So fresh equals fresh.sort. Key equals Can you write that this way? No. I'm pretty sure this is the default way of sorting tuples, though. I don't think I need a special key function for this. Those are all very large values. Okay, so if I sort them now, I can binary search on the list if I want to. I mean, I'm kind of taking a lazy approach here. Oh my god, I just had a really interesting idea. Hold on. I think I might... I think I might want to... I think I might have chosen to over-engineer this problem. Yeah, I think I'm going to over-engineer this problem. Thanks, Red. I really appreciate that. So what I'm going to do is I'm going to generate basically a number line of both endpoints. So the way it's going to work is there's this number line of endpoints, and let's say I find 3 to 5. I'm going to put a marker at 3 with like a +1 note on it, and I'm going to put a -1 marker at the end point of it. And then basically what I can do is I can pre-process this list to find what is the sum up to a given point. If I ever find a positive value, a positive non-zero value for the predecessor of that value in my list, then it means it's fresh. Tuples are immutable, so basically if you have a record that isn't going to change, then that's the answer. I'm going to way over-engineer this, just because it's fun. And then my endpoint is going to have a -1. Okay. Now I've sorted it. Now I'm going to reprocess this. Essentially what I want to do is I want to replace each one with the sum. I'm basically just computing prefix sums is all I'm doing. So I'm going to say for x in fresh, xy in fresh, I'm going to add to fsums So there's no reason for me to over-engineer it this way, but I'm choosing to do it because it's fun. Now, if I binary search for the value, all I have to do is check to see if it's non-zero, because that would mean that it's inside some number of ranges. The number is actually going to tell me how many ranges it's inside of, which might be useful to me, who knows. Let me refresh myself on Python bisect. I never remember how to use the bisect library. This will be a good excuse for me to refresh myself on it. So now, for line in F, ID equals int line strip. And I just want to know what the predecessor is. So it would be bisect left, I'm pretty sure. This equals... How does the key method work here? Bisect movies 1960, key by years, attribute getter unreleased. Okay, I see it. So we'll try bisect dot bisect left. Return the index to insert item X in list A, assuming A is sorted. Oh, do I actually want bisect right then? Maybe I misunderstand what the right and left refer to here. I'll try both of them. One of them will work. I don't really care which. This would be fsums id key equals lambda a 0. That, and it's going to return something, and it's going to return fsums that, and I want to get the value at index 1, and I think I'm supposed to do what now? If it's fresh, and I add 1. Can't wait to see how much this blows up. Answer's too low. Okay, so is it bisect left then? That also gave me 533. That doesn't inspire confidence. They are sorted. What happens if two are at the same location? What if an endpoint at... Oh no, I've over-engineered myself into a hole for no reason. It just occurred to me, what if the endpoints are the same? Does this work differently? It was too low before. Okay. Was I right before? Does it need to be bisect right? Oh, that's still 14. Why do I not understand the difference between bisect left and bisect right? I feel like I just don't understand left versus right here. Insertion point for X in A to maintain sorted order. Comes to the right of any existing entries of X in A. Yeah, I was trying to over-engineer a solution when I think that I can probably brute force this much more easily. I can abandon this approach, but this approach should work. I was kind of thinking that it would be fun to try something a little harder. I think I might just go back. Sometimes it's fun to, like, envision a way that you could solve a problem and then, like, try to tackle it in that different way. I don't think this is working for me. Let's come back to this. mean, I don't think the input's so large that I can't just search them all. It doesn't really matter. I kind of want to go back and look into my other solution. Start bringing their spooled inventory to the trash chute at the back of the kitchen, so they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient ID range is considered to be fresh. Okay, in an ironic twist of events, the way that I was setting up my problem before was better. Okay, so essentially what I want to do is if I see that there are an active number of ranges then I want to add up however many there are between me and the previous endpoint. Basically, when you start a new range, I'm adding 1. This number is part of one new range, and the -1 is you are part of one less range. Because then I can do a prefix sum on this to compute the number of ranges that any given value is a part of. I'm still missing how I handle situations where I have 2 endpoints shared. R count is greater than 0. Then F count plus equals A minus fresh I minus 1 0? Does that work? I think that doesn't work. Let me use their test case as just a test bed for now, and I can also maybe make my own test case. See, this considers 14. Oh, there's like an implicit +1 here, isn't there? Because Because I'm not taking into account both endpoints, right? So when I hit the 5 here, I'm doing 5 minus 3. Then 10 to 12. Oh. Yeah, that doesn't work. Like, that's gonna give me the right answer. There's no way in fuck that's the right way I should write that. Yeah, okay. Okay, so this approach is fine, except for... There is definitely, like, a segment tree implementation I could do here that I kind of don't want to do. There's an easier approach I can take. I've once again tried to be too clever. There's an easier approach I can take here. So what I'm going to do here is I've already sorted the list based on left endpoints. I'm just going to look at the next guy and say, hey, if we overlap at all, then we should just join. So I want to know whether or not my right endpoint is greater than or equal to greater than or equal to your left endpoint. This is gonna work, but this is annoying. Oh, this is annoying code to write. Okay. While I+1 is less than or equal to fresh, and fresh I+1 well, B is greater than or equal to your left endpoint. You do have to handle the edge case, though, where you're, like, completely incorporating another one. If, so that would be if B is greater than or equal to fresh I+1 I. Otherwise, it's B is equal to fresh and then finally combined pen. I mean, I don't even have to do this like append nonsense. F count is equal to B minus A plus 1. I don't know if that works. Well, let's try it on the other test case. Rather than just like blasting this out, let's try it on the other test case first. It does give me 14. In which case, I'm definitely correct and also a genius. Okay. Yeah, that was a little more annoying than I was expecting it to be. I really tried to engineer something that effectively used prefix sums in order to simulate a segment tree or like an interval tree doing like interval overlapping, but I wasn't willing to debug the mess I was creating. Ain't that the way it is sometimes? Sometimes you just create a mess that you're not willing to fix. Anyway, I guess see you tomorrow for another day of Advent of Code. So.